Alright, so that's why we have the special consideration using a toll booth, using a caravan. And the caravan actually need to work together. If we have the requirement, and then this one, the same as the consideration of packet transmission and propagation. Alright, that's it. That is the purpose we want to have the mapping from caravan to a bit and a packet. Alright, about that one, any questions? Well, if no, let me continue. Transmission delay and propagation delay. And in fact, we have the processing delay. How to have the calculation of processing delay? Well, it's somewhat like a given value. For example, we need to process by checking bit errors or something else. It should be a given time period. So this that one is a given value, so we don't consider that one at this moment. However, we doesn't feel if we want to have the information about queuing delay, how to have the information of queuing delay. Here we have the curve, average queuing delay and traffic intensity. Traffic intensity here, maybe we have the new term, traffic intensity. What that means, traffic intensity. If we have the packet length, and this is the rate to have the packets arrive at maybe the queue here. And we have the capacity R. So you can have L multiply A so that you can accumulate all the bits to be here. So L over R actually is the all bits input. Right? All input bits and over the capacity. So it's somehow like the ratio to know. Then we have the suitable capability to process the current input bits. And that's why we have the ratio to have some corresponding mapping to the queuing delay. So we have these input bits and the capability. So L multiply A, the input bits, over the capability R. And here we can call this term traffic intensity. Well, about this one, we have this, and in fact, we can have the reference value 1 here. And also, we have the reference value 0. So here we have 0 and 1. If we have a reference value 0 or near 0, it says almost no input bits. Of course, we have bits, but doesn't mean we don't have the 0 bits. So we almost have 0 bits. And how about the current situation to provide you the queuing delay? It's quite small. So I think someone like right now, you try to buy the lunchbox and see no people before you. So you can possibly get the lunchbox directly if all the lunchbox ready for the customers. Well, for that case, we have average queuing delay almost 0, and here we call it small. And how about the situation L A over R larger than 1? Larger than 1 says we have the input bits exceed the capability. Exceed the capability, that says, can you process this one properly? In fact, no. Because of no, so something like you can try to think about a scenario. Perhaps someone tried to wash the dishes. Consider an example. of washing dishes. Okay, the example of washing dishes. And maybe I have my capability to take the dish to wash. And maybe you have a line to pass the dishes to you. If you want to take the dish, but however, you have a lot of dishes to wash, and then pass through the conveyor belt and going through maybe some space to you, but you cannot process that one. However, you tag it. If you don't have time to tag it, what happens? Just allow the dishes to come in here, but you don't have the capability to process the one. Has it drops and then broken. So this is a real situation. If you don't have the enough capability, even you can receive a lot of, for example here, dishes, but you cannot process. If you cannot process and you don't allow the dishes drops, so you may put the dish maybe aside, and so that you need to process later. But put it aside, 1, 2, 3, you may have many accumulated dishes, so you cannot process that one. So you may have this case, congestion. All right, so this one actually no enough capability. Then you have the congestion, and then you will have the agitation. Queuing delay is really large, and actually it's extremely large. All right. Okay, maybe I have the wrong mapping. This one. Previously, I didn't know the case here. Greater than 1. But even not greater than 1, but at least near 1, what happens? The situations are like, right now, it's really large and near congestion. If we have a congestion here, more water arriving, so you cannot finish. You cannot finish, so how about the delay? I don't know, extremely large. In fact, here we don't know, it should be infinite. Infinite. Actually, it's the infinite. So we have the infinite delay for the current case if you cannot process that one properly. Infinite, consider the congestion. You don't think it will be infinite, but if you try to line up there, you can feel what is the real situation. To have infinite value, of course no, but at least if we have the calculation using some formula here. So let us use the formula here. This one, actually this is a formula, and formula from MN1 queuing delay. And if we have MN1 queuing delay, you can look up by using Google, using the term here, MN1 and queuing delay. And then we have a formula. And the formula here, in fact, we have the calculation. In fact, we can have infinity. So infinity, once you reach the traffic intensity around 1. But going beyond, and then also infinity, but we don't want to consider that case because that case, it is not a stable situation. So here, non-stable. And this one, stable region. Stable region that says it should be controlled under the stable region so that we expect everything working normally. So this is a stable region. But beyond that one, it is a non-stable region. So normally we don't expect that one. What kind of a situation? It will be unstable situation. This one, congestion. If we have a heavy congested situation, then it's not the normal situation we expect. So of course, we do not consider that one normally. But sometimes it happens. So that's why we don't know the heavy having a congested situation for sure. All right, so in fact, you can look up M1 queuing delay and so that you can have the curve. And what kind of formula so that you can have the curve? I think you can use Google to check M1 queuing delay, then you can find the formula. And that formula can that you have for the current graph like this. All right, so this is a queuing delay. In fact, it is somehow complicated. And in fact, we can focus on this and so that we can have a calculation methodology and then we can have a queuing theory. Well, you may feel ridiculous. Queuing, you don't like it. But why we will have the queuing delay? You should understand even it's a problem, but we need to know this problem, how to have some information to get a calculation. Once you know the calculation, sometimes you can estimate the value of queuing delay. And if you can estimate the queuing delay, then you can have some actual mechanism to alleviate the congested situation. You can alleviate the queuing. So that's why we don't like it, but we have the principle, and the principle it is called queuing theory. So if you want to have some tool to have the calculation, you can refer to queuing theory.